Welcome everybody to this last RPIrates of the spring 2025 term. And tonight we are going to talk about one way that you can organize your projects to deal with that scourge of creep that happens when you've done all this hard work on your analytical code, or perhaps your Shiny based application, and then new versions of critical packages come out, and other things change, and versions of R change, and it puts your work in jeopardy. And it's a package that the center of the discussion is this package called RenV, or R environment. And this, the slides that I have here are my own creation, but they were inspired by this module that was taught at this UC Santa Barbara software carpentry thing. And I don't know what, I haven't seen any slides associated with that actual thing, but I did see sort of a syllabus of that discussion. And oh, I'm sorry, I see what I did there. That's pretty clever. Give me a second, go back to my, that was the page. Anyways, so I think a lot of us, let's assume we're being very methodical, very careful in our packet, in our code development. We're going to make this so we could share it with somebody. So we're using R because R is open source. You know, if I've got somebody, a colleague across the world, I know that I'll be able to share that code with them. They can get R. They can get presumably the right version of R. I'm doing the right code techniques. You know, I'm using relative paths so that code can land on that wherever it lands in their machine when they expand their, when they clone that Git repository, it's going to work, right? I've written really clear code. And I'm doing the other things right. I'm using, you know, sensible naming conventions, and my code is organized. I've got, actually I have comments, you know, so surely this is code that is just going to persist and last and work, okay? And by the way, do people get the reference here? It's a troll under the bridge, and you are the happy little goat trapping over the bridge, okay? Billy Goat Scruff, okay? And then reality comes. What does reality do? You know, your version of R gets upgraded, and all of a sudden things don't work, or packages get released. You know, updated versions of the packages get released. So when your colleague across the world goes through and does your diligently placed install packages, they're not installing the same version. They've got a different version of R that they're using, and they're installing packages, and they're installing different versions of the packages. Maybe some of those packages depend on something that it has a new dependency. All of a sudden now your code, which worked for you, isn't working for your colleague, or the code that you worked for you a year ago isn't working now because of the system changed underneath you. You know, on the cluster, we try to update our version of R at least once a year. So how do you make your code reproducible in time and in space? That's really the question. How do you deal with what's called dependency hell? This is an official term. This is actually what the software industry calls it. And you know, in general, and if we've done anything complex, we've seen it. We even see it sometimes on really complex R packages. As we install those packages, we see all the dependencies getting compiled, and then we see things like we see that the system level packages, that those packages, those R packages are dependent upon all of these issues. So that, does anybody recognize this XKCD image? This is,
Yeah.
this is a paradigm. This has been on XKCD for a couple of years. You know, this amazing stack, software stack, and it's all dependent upon this one piece of code from Alaska that's been taking care of this since 2000. This realization that these versions can be shifting under us, and how are we going to track that? Here's a, this is a little example of the kind of thing that can happen. I install X and it's dependent upon version 2. I install package Y, it depends on package Z and version 1. And somehow I'm able to get that to work. But eventually Z gets updated, and it no longer its dependency has changed. That package Y dependency has changed. How do you deal with that? And we see this sometimes. It happens in R. A package manager, the person who's the publisher, the creator of the package, sometimes they have very aggressive requirements, so that when a package is created, the creator of that package determines not only what packages themselves are required, but the specific versions that are required. And oftentimes they will require the newest version of a particular package, and that can cause problems, because that means it's against the philosophy of, like, I should be the most lenient. If I'm going to require a package, let it be like the oldest possible version of the package. But some developers are insistent upon the newest one that's available. So these can create these reproducibility issues, and we see them just over time. So to start solving the problem, to have a mindset about how do I get around this so-called dependency hell, you need to be cognizant. You're going to have to be cognizant of the versions of all these packages that I'm actually using. You have to be cognizant of what other system dependencies there may be, and you have to have some sort of strategy for of R, because of certain packages that he must use. But I need to be able to manage with both of them. I have to be able to switch back and forth. How do I deal with that? So to understand that, what this REnv package does, it when you've enabled it, when you install REnv and you enable it in RStudio, in your project environment, it does certain things to keep track. One of the things that it and I'll mention it in a subsequent slide, but it tallies up all of the versions of every package that you have. It keeps track of that exactly, and it also, the package provides a way to manage that. So if you decide that you are able to upgrade a particular package, there's a introduces to update that lock. And you can do that with people that you're collaborating with. It's not just this one person. There's a way through the Git process, so it works with Git, so that if I create it and my R lock says I need 1.0.1, I share it with you, and you say, well, actually, we're going to have to update that 1.2.3, okay? You do that through this process and it gets updated. We'll talk about that. But it also creates, it reorganizes on your machine how the hierarchy of how libraries and packages are managed away from the default way that it's organized to the way that you can have this multi-project way to do it. And so I basically talked through that. And this is a figure, and we're sort of familiar with it. You didn't necessarily realize what was going on here, but when you install a package, and you're not doing it in a project-oriented way, you're just doing it like most of us do. We just get into RStudio and we install stuff, and then it's there. Okay. When you're installing it into sort of a system-wide library, and we have to use kind of different words here. When I'm referring to library in this context, I'm not referring to that library command that we all use to load a package. A library in this R environment is how packages are organized. And you can have multiple libraries. What I'm depicting here is how we usually do it. We usually have one library, that all the stuff that's installed for me, okay? And anything that's installed across the board, and anything that's installed for me, it's all shared. But what does that mean? That means I work on a project with Aaron, and then I go and I work on you. I update my code so that my code works for you, but that breaks Aaron's code because Aaron actually needed that older version. And so that's exactly the problem that we're talking about. How do we firewall that? How do we make it so that I can switch between Aaron's project using the old ancient version of the package in your environment that the required packages that are newer, okay? So this is just reiterating the fact that without this environmental management thing, install packages just puts it in. It just puts it in, and if you update a package, it just updates it regardless of the project, because it thinks it's essentially one big project. It's not aware of any walls between your projects. So this is how RN thinks about it and manages it. For each project that you define, it's creating a separate library for that project. And then when you're in that project, when you install, you're installing it for that project. And it'll get logged in that RN lock file. So if I install old version of something here for this project, I can install a different version here. I can install a different version here.
So the version that you're installing is simply specified by the time that you do the installation. Are you saying
so
specified a version?
What's going to, it's not a time thing, it's a project thing. So what I'm not mentioning here is part of this is utilizing RStudio's project capabilities. So we're creating a new project. So we're going to think of AltTab, okay? You think of that as it's formally defined a project, which is really just some management files and stuff like that. I'll show a picture of this. When you initiate a project, or when you initiate your project, you can specify that you want to use RN with it, okay? Or you create a project and then later, either through a command line or through the wizard, you can say, I want RN associated with it. But in any case, you're using the formalism of an RStudio project to sort of, it's kind of creating metadata in the file, and it creates an RProj, a .rproj file. in your working directory. I should say what a project does, just to back up. Is an image of your environment, even your workspace, if you want. So, and our project could be just sort of the package that were installed. It can be the state of the data. You can actually have it pack the entire environment in an R data file. You can even have it store what the panels are doing, what's open, if you wanted to. So, but that's if you enable it as a project. Okay, so this is all being done in a project with RMs turned on. We've got this added tracking of all these versions. So it's, you could ask the question, why isn't it just built into projects? They work very closely together. So this is kind of the high level of what's going on. I just described this. This is sort of a do as John says, not as John does. Because every time I study like project management or things like reproducible environments in R, I look at this and say, this would have saved us on something, right? So imagine you're just starting out. You're going to create, I don't know, a Mars app. The first thing that you do is you make it a project, okay? And then when you're making a project and you give it the name and all that stuff, you are going to decide, do I want to associate RN with it? And by doing that, it's not going to, in terms of your personal interaction with it, personal coding, one-off coding, it's probably not going to immediately impact you in any way, but it will instantly impact anybody that you share that code with through, if you commit your project to a Git repository and they clone it. When they go into your code, it's going to, when it goes through the installation process of everything, of all the packages you require, it's going to look at that R lock file and it's going to install the exact versions that you shared with them. That's the reproducible part. That's what's different. If we just did it, but if we didn't have that R environment, if it just was a project and we shared it, it would go through and install the packages that you list, but it's going to do whatever it pulls off a CRAN, which could be different than what you had. That's the magic sauce right there. And so the point here is that you don't have to do it up front. I'm making an argument, why not do it up front? Why not? You know, if you're going to the trouble of doing our project, and then but you can also do it if you've already got an existing project. You can go in and add it afterwards, or you can do it from the command line. This is this kind of helped me think about it a bit. And this is probably how I would do it. Is I would just go in and just do it in the console. But you know, it's a CRAN package. Just install it, load it, and when you run init, the init function, it's going to go through and create the various support files automatically. It's going to look at what you've got installed. It's going to create that lock file. It's going to everything's going to be documented, and and it's the one thing that is, the one potential gotcha that I is, so it's creating this folder. If you're used to doing Git operations from the command line rather than through the RStudio interface, you may have to explicitly specify to add the files created by RF. Because I don't think it somehow magically knows. I think it might magically know if you're doing this all within RStudio. Okay, so that's one gotcha that I'm not 100% sure about in terms of the stuff that's created. But this is a depiction of sort of the logging structure that renv automatically creates when you do that in net. And when it's writing off files to store results, it's not doing it in binary, it's doing it in JSON. So you can pop those open and just view what it has stashed in there. So you can actually look at, if you open up the log file, you can see the packages and the versions. It's all documented inside a JSON file. And you can, it talks about how you do the update here. You install a new package or you change something, you leave the package, you do snapshot, refreshes your log file. Right, this is this. So I know it says this is what you're supposed to do. I guess the question is, I'm not sure whether when you do it in RStudio, because RStudio Git, which I'm not very familiar with because I do it from the command line, it might be dialed into renv. renv might, so it's something to take a look at, but and that would have to be updated each time. Each time you're changing those RM related files, you would have to update it. Okay. This is really cool. This is what happens. What happens if there's actually a conflict? Like what happens if you go and change something and now, I do a Git update and things have changed. It'll tell me that there's a conflict, and what I can do, or actually this is a situation of where somehow the wrong version of the package gets installed. I check that, it sees that it is not correct, and I can do a restore and it'll back it out. So it'll, and how have we done that when we do it manually? Somehow we figure out that there's a package that's the wrong version. We have to do a git remove packages, restart our session, find the right package, and explicitly install the package of the right version, and now we're back to it. This is doing it. This has an approach to do it automatically. We do it RM restore, and it'll do all of that automatically, which it would be numerous times over the last couple of years, whether it's IDM students or data analytics research students or other project students where we've had version problems, and we could have fixed it in this.
You go back like a few slides to the one that has the projects with their different libraries.
Sure, that the hierarchy, this one, that one?
So if you're doing this library management with RN,
Yeah.
and you have, you're working at multiple projects at once, you've their own actual projects, so they have their own libraries. And project 1 needs version 1.0 of the library, and project 2 is using version 1.1.
Yeah.
I assume both of those libraries, when you switch between projects, you don't have to restore. Because
No,
they're
yeah.
both in the global package cache probably.
Yeah. Oh, yeah, I should have said that very explicitly. Nothing is actually uninstalled.
Yeah, okay.
Yeah, that's a huge point. Thank you for getting me there. Yeah, this is a really interesting thing that this versions of packages to coexist. They, here, this thing, okay? What this is actually, this is dependent upon like the version of R. Okay, and you'll notice sometimes, I don't know if you've ever encountered, I've certainly have encountered this. Like if you've got a version 3.5 of R and you got a version 4.1 of R, there's actually parallel hierarchies here so it sort of looks like this, but you can have these different system libraries. So so you can, but it doesn't, it still doesn't have like parallel packages. R is really kind of weird about, because we've had problems where a package was installed under 3.5. I need the package under 4.1 and it won't let me, and it persistently won't let me install this other version, this newer version, because this thing's over here. And I'm installing some other package that's dependent upon this. This is not accessible. This is too old, but because this is here, it won't let me do this. So you have to figure out how to get rid of that. That sort of is a problem that's taken care of by.
Yeah.
Go ahead.
So the system library, let's say it's R4.2. Right?
Sure.
To establish all these projects, the libraries that are compatible with R4. Fast forward some X amount of time, there's R4.4. I built a new series of projects based on libraries and their compatibility to R4.
It's not going to work here though.
No, so what I'm
Go ahead.
getting at is that while this hierarchical structure is valuable, we're still going to be constrained based on that system-wide limitation.
So, yeah.
Because it has a couple of problems.
Yeah, so you're right. I should say, I think you're right, but it's usually not it usually isn't a problem, but
This is a forward. This is not.
yeah, no, it's so you're posing an interesting question because it's this problem. So I was thinking, what about those situations where you need some of those 3.5 things and you need some of the 4.4 things or 4.2 things, whatever. And is that going to be properly managed?
Or you can always ask the question.
Yeah.
In the system library of, let's say, R4.3, whatever.
Yeah.
Is it possible to establish a project with depreciated libraries? Or I would need to basically just create a separate hierarchy.
So I think, well, I certainly think the safest thing is that you would, so it's really hard. Okay, I should step back. This RM doesn't manage, RM doesn't manage the version of R that you're using, okay? That's another thing. And that's actually, that's a package called RIG, R-I-G. And RIG is a way to manage, to deal with multiple versions of R. okay? When you only have one version of R on, so this is assuming one version of R. This having the multiple system directories dependent upon the version of R so R can like see into those, and sometimes it can deal with it, and a lot of times, because obviously it does. Because if I'm installing a package with a newer version of R and it's looking for binaries from a newer version of R, and the old ones are not acceptable, it creates a problem, but it sees them. Done in the past, because it creates more problems. We often will have, we'll just nuke, a user's like old directory to eliminate problems. But that's the level of work that we're doing. That's totally fine. Where does it show up? It typically shows up. We got a student in Intro to Data. They took Intro to Data Math 2 or 3 years ago. So they were on the cluster 2 or 3 years ago. And then now they're in, in the fall, they're in data analytics research. And we've moved the version of R forward, a couple of versions. And then now they're trying to install some critical package, and it keeps wanting to pull up these old things, and they're not acceptable. The solution to that problem is you look, you see they've got an old R hierarchy, we nuke it. And then, it's an interesting question of, we've got that, how's it going to properly deal with, what if I'm unfolding, what if I clone a project that was created 3 years ago? How does that deal with a new version of R? I know it's going to try to install these packages. Maybe it can do it from source. Maybe it'll do the right thing. But so that's sometimes how I've solved weird version, either old, packages were created under old R with no binaries available for the new. That's always solved by installing from compile it. Okay, and that's going to be put in the right spot also. So I don't know if that's completely, some of this is.
So is it possible to use regular R now?
Yes, oh yeah, definitely. Oh yeah, you definitely can. And it comes up in the context. I didn't want to go down. I've got much less experience with rig. I was like, oh boy, there's a lot here. But these tools, so I guess the thing to keep in mind is, it's generally positive, the former RStudio company, and they're dealing with some pretty robust issues. Okay, so we got that, where you can create it there. We can do that. We can do this is an example of init from the console. These are things that are created. Don't forget to commit them. And this is how we restore. Okay. Okay. This is kind of getting into depth about the whole restore thing. And again, what this will do is, this is restoring in a context of the project you're working on. This is not upgrading tidyverse across all of your libraries. This is just all of your projects. This is just dealing with the project that you're focusing on. And it also goes backwards. That's the other thing that's important, is if for some reason something got updated, it will, when you do a restore, it'll move that, it'll regress that package version. And to the point, I think that you were making or whatever, it keeps around all the old stuff, and it never forgets. So So this is kind of reinforcing the fact that you need to, when you're doing that git commit, when you've turned on, when you've enabled our environment and has created those files, you need to explicitly, Module RStudio doing it for you. You need to explicitly commit all of those files, add and commit that whole hierarchy of RM stuff. And when your colleague opens it up, they will, it will automatically update all that stuff. And then, as I said, as they update packages, the state will be preserved by that snapshot, and then they have to obviously commit those changes. So it's a set of files that you have to be cognizant of. And this is kind of an issue because, in some of the projects that I've been working on, we've got our little version files, right? Our little version.csv is our little trick for showing from live app what version of the code is. And that doesn't get updated. It's like update it. And people don't update it. So remembering to commit this stuff. There might be you might want to be thinking about some automation to do some of this stuff. Okay, so here I mentioned rig, okay, and so it's in the R lock, it's going to document the R versions, but it's not going to manage the R versions. So it's going to keep track of that for you. One of the things that's kind of scary is if you're doing this in a universe where PANDOC is important. So PANDOC is the aircraft carrier that kind of powers our Markdown. It's a big chunk of separate code. So PANDOC is not implemented in R. There's an R interface to it, and PANDOC is a system module. So if you've got drift there, it could bite you. But it probably at our level, it's not that big a deal. But there are people that do book publishing with R. People like Hadley Wickham who are cranking out books, and they're authoring those books in R. And so, what's that?
That's a better person.
It's amazing. It's amazing to flip through some of these books and say, they did this. This is a big fat Markdown, and it's done for real. And the whole thing is done for real. I aspire to be able to do that someday. It's so cool. And
Do you have any examples of like a sample Markdown file that can be converted into a book?
well, they're easy to find. Actually, if you just go if you just Google on Bookdown, and POSIT site. So all of the POSIT documentation is done. I think the POSIT documentation that there's GitHub repositories that have them. It's pretty beautiful stuff. It's kind of a hierarchy. If you can take our Markdown and then you create hierarchies on top of that, nesting. But the goal is, I've got several books, several R books, not just Hadley's books, but some other R data science books that are just beautiful works that are done that way. But
I'll challenge myself to want to do some.
sorry.
I'll challenge myself to want to do some stuff.
Yeah, I should share with you. There's a couple books that ought to be the basis of a course. I mean, that's how good they are. But anyways, so as you obviously keeping track of packages is not, and keeping track of packages is is an essential start, but it's not sufficient. And when we start thinking about the other things, the other externalities that could cause our reproducibility to crash, you start getting into, what system environment was. Like, for example, we've got our own little reproducibility experiment going on right now where we've got, we just fired up for Keith and Nidya. We fired up node 4, the long lost node 4, and node 4 it's an Ubuntu server, not a Red Hat server, and it's got more memory, and it's got GPUs. It's a hot little machine. It's a little sports car running around, but
I switch all my bookmarks to node 4.
you're not going to be able to get there because we control the access to it. And it works great when it's not crashing. Boy, the systems people crashed our cluster today for us. It's back up. But you got to understand, that got rebooted by Sean pulling strings from Alabama, where he's in the back of a fishing boat.
It's perfect timing too. I was trying to push the changes after my computer died in the class. And as soon as I come home trying to sign in, my phone's not.
It crashed as you were walking out the room.
Yeah.
So anyways, so there are amazing other ways. So if the purpose is, so containerization is one approach to keeping things alive. Like if you really wanted to wrap things up in a bow and have a good chance that things are going to reproduce well, the way to do it is just package everything, in an image that captures, the version of R, all your packages, all your code, lock it down, and then fire up a Docker image when you want to use it. And that's a viable model. And that's something that, you could run a course that way. You could literally, if we wanted the students to have a particular locked down set of capabilities, we could create a Docker image that is what we wanted to share with that student, with the students. And then we could have them, whether it was on a personal machine or on a server somewhere, we could just have them run those Docker containers and everything would be perfect. Or if you wanted to share your code, it's a way of sharing apps. We could, rather than hosting our Shiny apps, we could just tell them to do a Docker pull from Docker Hub, and they've got a copy of the app. That's a perfectly fine way to do it. Perfectly acceptable, except that they're running it on their machine. So there's a whole vignette with RN on how to leverage Docker and preserving environments. So I'm going to link to these slides from the event page that I created, and probably also I'll link to the video and the slides from the RPIrates page. But there's a whole set of resources here. These are all linked, and several of them are more project oriented, like that using RStudio projects. That's a whole tutorial on project management that gets into using using projects. And some, but most of these are RN. And Hadley Wickham, of course, in his project workflow, and environment preservation. And that is, I believe that's it for my slides.
Another question.
Yeah. Do you want me to go back to something?
No. What the slide for? Just curious about how, like RN might handle unnecessary libraries, like say you're working on a project, maybe from another idea, but you install a library, you use it, and RMs captures that, and you realize that it's like, oh, I don't actually need that, but will it?
So that's a really interesting question. So, I don't think renv takes care of that, but, so let's talk about a couple different things. There are tools, there's a tool in the MISC library that if once you run the part of your code which loads all your libraries, you then run there's a function in the MISC library where you select your source file. It's kind of weird. It's kind of done from the console, and it checks your package utilization. It actually checks all the functions and the packages they're from, and it sort of links it for you. You go through and you can see this package was never used. These functions were used from this package. Okay. So that's a helpful tool for optimizing that. But there's another tool, which unfortunately I don't remember the name of, that I just discovered this week, that its job is to help you create what is it called? I think it's called Dockerizer. You can check, somebody could Google that for me, but it's called Dockerizer. And its job is to look over your entire project directory and basically construct your Docker file. And this is really of interest because it figures out what your system dependencies are and the libraries that need to be installed. So if you remember when I was going through the Docker stuff last month, when you create your Docker file for an R Shiny app, the first part of it is all the system installs, all the things you have to add to that image at the system level for the packages you're going to install to work, all the additional things, okay? So what Dockerizer does is it figures out, number one, the best base R image. And base R, I'm using like lowercase. It could be like a tidyverse enhanced R image. Okay, let's call it a starter image rather than base R. It figures out the best starter image. Maybe it's got tidyverse and Shiny installed and all this kind of saves you all that trouble. Figures out the additional things you need. Then it figures out the packages that need to be installed. And I think it optimizes that. So that I can be checked on that, but I think I read that it because I remember thinking, oh, that's cool. I need to do that. But the idea of having that something automatically do that, I don't think you've ever really went through the process. You may have edited it, but Dockerizing can be tricky. Keith, that LSAP, are we serving that on a virtual server? That's yeah. That was a real bear.
Until you see what I'm gonna do.
What's that?
But until you see the update this.
I think what it was, well, part of that was, I think we were really early on in our really knowing how to.
There's a lot of lessons.
Yeah, a lot of lessons. Are there any other questions?
Yeah, I have one more. So it seems like, as long as you have RNs incorporated in your project, really to just run admins. Based on how your size are structured, it's like. No.
And it's when you get into the collaboration that so snapshot is essentially the update.
Yeah.
Snapshot, and then don't forget to do your Git stuff. The restore is when your colleague monkeyed something up.
Yeah.
Or you messed it up.
So then down the line though, you're done with your project, it's pushed on Git, then, 2 years later, somebody's like, oh, I wanna try to run that. They could pull, or they pull in the repo, and do they have to be aware that, of how to use RNs themselves? Like, what if they've never seen RNs? They clone the repo, and they never run like, and then, the way that they auto do that?
I think when you open the project, because it's a project, okay, that's the thing they keep important is there's that extra stuff going on,
Yeah,
that it's an R project. I think, and based on what I wrote down, I think that it automatically is running, like there's an activate script and stuff like that. So I think
and
it's churning through that.
I haven't used projects in our studio, so I don't know, but like, if somebody clones the repo, do they have to load it as a project in our?
I believe that, I think they have to load it. as
There's
a
like
project.
no way.
So that's a good question. I don't know if you can avoid it. I feel like,
I'm not suggesting someone would intentionally be trying to, but like, if
No,
I
so-
know better, maybe.
well, no, I think that, so we've had, this has been years ago, that we had some grad students who did things as projects. We had a couple, I think. And it sort of, projects can be weird. Because you have to remember, like, let's say you've got several lowercase projects. They're not formalized, but then you've got Aaron shares a project, and it's a project, and you open that project. Okay, what I remember is you can start navigating around and it still thinks it's in the project. Okay, and that could screw you up. Okay, because the environment could be weird. So you kind of have to exit the project. Like, you have to be deliberate about, I'm going from this project to this project to this project. So you have to be of a project state of mind if you're touching projects.
Yeah.
I do think, my memory is that when you interact with files in a project, our studio knows it sees that .r project file, our proj file. So
Yeah. Okay. And then I guess.
lots of unanswered questions that I will answer over time.
Yeah, that's good, that's good. That brings in one more question that I think is much simpler, but it's back to the two hierarchies of libraries. So if you're just used to always working in your non-project based R studio, and then you open up, so you just have your user library, right?
Yes,
And then you switch to somebody's project.
yeah.
Then you can just, if you close the project, you're just back to your user library.
Yes, that's correct. Yeah, that's what I was trying to say. And it's when you don't do that, that you get screwed up.
Yeah.
Because you're essentially popping into, you're switching environments is what you're doing. It's like, what is a project? Well, a project is all this stuff rolled up. So you're like, if you can imagine, there's a way to think of it is project A. You've just run through, you've got all these data frames and functions defined, okay? Now, I'm going to switch to project B. I go out of project, I close down project A, I go into project B, I'm in project B. I see it opens up with totally different set of data frames and that. It's like, I go from one to the other. How does it work right now without that formality? This directory to this directory, I've got multiple apps. Looking over their shoulders, they'd be in shock.
Yeah.
So, but it's difficult to introduce that there's so much to introduce with these, these formalisms. That it's hard enough for people to wrap their minds around, the basics, so.
Yeah, I just never even thought about, I did my undergrad in outside, that was very applications development oriented, so everything was very well organized in projects, but ours has always felt like more scripting, like short things that usually you don't need that level of organization, so I don't even follow.
But I think if you, so think about your typical software development. When you're developing an app and you got something like RStudio, or not RStudio, Visual Studio is going to kind of naturally be project oriented.
Yeah.
Okay, when you open up something, you're opening up the project, you've got that whole file hierarchy, and you're just concerned with that. Okay, and it's going to make it really hard for you to interact with non-project things.
Right.
Okay,
Yeah.
okay. What we're used to in our studio is more one-offy, loosey kind of thing.
Yeah.
What projects in our studio is trying to do is introduce that formalism. So you're just thinking about this one thing, just thinking about this, and it's something that we need to work harder on. So, anyways, I think with that we say so long, farewell, auf Wiedersehen.